The first term has an exponent which is negative 1. The second term has an exponent which is equal to minus a half. So we know that minus a half is twice. Sorry, minus 1 is twice minus a half. If you multiply minus a half by 2, you will get negative 1. Therefore, we can rewrite this equation as a quadratic equation. It's exponential, but it can be written as a quadratic equation. So we can write this as x to the power of minus a half squared minus 5x to the power of minus a half plus 6 equal to 0. Right? And then we use the k method. So let k be equal to x to the power of minus a half. This is equal to 0. Right? Then we substitute, right, as k squared minus 5x, so 5k minus 5k plus 6 equal to 0. Okay, now it's a quadratic equation which is of grade 9 and 10 level. So you end up having k plus 3, or rather let's put it k minus 6, or plus 6 rather. So I'll put here minus 3 minus 2. So k minus 3 times k minus 2. So this will give me k equal to 3 or k equal to 2. Okay? Then we need to find the value of x. So we'll say when k is equal to 3, we substitute k equal to 3 there. So we end up having 3 equal to x to the power of minus a half. Okay? Remember, we want to solve for x. So x is going to be equal to 3 to the power of minus 2. Alright? Then the answer for x will be equal to 1 over 9. Okay? Remember, the reciprocal of x to the power of minus a half is equal to negative 2. Right? So that's the first answer. Then let's see if when k is equal to 2, we can get a solution. So when k is equal to 2, we'll end up getting 2 equal to x to the power of minus a half. And this will give us x equal to 2 to the power of minus 2. Therefore, x is going to be a quarter. Yes?
I use the value minus plus 1.
What?
I use the value minus 3 and plus 1 for the k minus 3, k minus 2.
No. It means you factorize it incorrectly. You see this, you have to be very careful when you are factorizing. Right? The best answer, k minus 3 times k minus 2. The reason because if you use FOIL, you'll come back there. Can you tell me your answer that you got? Let's check it. You got k minus 6,
K plus 1.
k plus 1. Let's check this. Right? K by k will give you k squared. K by positive 1 will give you positive k. Minus 6 by k will give you minus 6k. Minus 6 times positive 1 will give you minus 6. You see the problem? Because you are supposed to have a positive 6 there. The way you factorize it, you end up getting a negative 6 instead of a positive 6. So you get the first term right of the trinomial and the second, but the third one will be incorrect. That's why sometimes when you factorize, you just have to do a quick check of your factors. Alright? Unless if you're 100% sure. Okay. So that's what you're supposed to do. Now, this question, it can be done using another way. Okay? This could be, maybe I would say, the easiest way. Right? But it can also be done in a different way. So I'm going to show you method 2. You can call this one method 1. So method 2, you just use your knowledge of fractions and exponents. combination of both. Okay? So let me just show you. Is there anybody who approach in a different way? Okay. So method 2, so you're given x to the power of minus 1, right? Minus 5x to the power of minus 1, minus a half rather. Then you have got a positive 6. This is equal to 0, right? If I use this definition here, x to the power of minus n over x to the n, and make the exponents positive, I'll end up having 1 over x minus 5 over x to the power of a half plus 6 is equal to 0. Okay? Right? Then you need to find the LCD. What will be your LCD here? Sorry, girls, can you be part of the lesson, please? What will be the LCD? One of you can she tell me the LCD of x and x to the power of a half? What? No. The LCD here will be equal to x. Remember, x to the power of 1, right, is 2 times x to the power of the half. Therefore, the lowest common multiple of x and x to the power of the half is x. Okay? So, if I multiply every 10 by x, this will become a 1. Okay? Then minus, I hope you're following what I'm doing. Minus, here, I'll multiply the numerator by x to the power of a what? Of a half. Okay, let me just take you to the basics. Someone might be saying, what is he saying? Right? So our denominator is a 1. Our LCD is x. Okay? You did algebraic fractions last year in grade 9. So to simplify this, you multiply every term by the LCD. Right? You know this. There's no way that you got into this class and you don't know this. Right? So this one here, you just multiply it by x, like that. Don't be surprised. Okay? We want to eliminate the denominator. Yes, we find the LCD. It's only that you have never seen a question whereby one of the exponents is rational. That's all. But the concept of LCD is still the same. Okay? So the LCD is x, multiply every term by the LCD. These two will cancel out, and left with what? 1. I expect everyone to be aware of this. Then here, if you use the laws of exponents, x divided by x to the power of a half will give you 5x to the power of a half. Because the exponent here is a what? It's a 1. 1 minus a half gives you positive a half. Then, since we have a constant here, just multiply it by the LCD, you get 6x. Okay, then I'm going to rearrange this, and then we simplify it. Okay, so if I go to the next page, before I can then produce with any question. Is it making sense? Right? So I'm going to rearrange and start with 6x. So if I rearrange, I'll get 6x minus 5x to the power of a half plus 1 equal to 0. Right? I rearrange this. Okay? The reason I'm starting with this term here because this x here is twice that x to the power of a half. So I need to create that quadratic equation. Okay? So if I say let k be equal to x to the power of a half, I can rewrite this as 6x. Well, be aware of this, that this 6x to the power of a half, this will be squared. like that, minus 5x to the power of a half plus 1 equal to 0. Therefore, here I can end up having 6k squared minus 5k plus 1 equal to 0. Then your responsibility now is to factorize this. Can someone factorize for us? Okay, which two factors to add 6 and 1, right? Which two factors of 6 add up to minus 5?
Negative. Minus 6 plus 1.
So you've got minus 6, right, and positive 1, right? Is there another option? No. You can't say minus 3 and minus 2, okay? Because minus 2 minus 3 give you a positive 5, right? But it could also work. But I'm not going to use that one, so I'll say 6k squared minus, if I split this into 6k, right? Remember, you know, those of you whom I taught last year, you know this. Right, 6k plus what? Plus what? Plus k, then plus 1. This is equal to 3. Right? Then let's factorize this. You get 6k times k minus 1. Right? That one will also become k. Now this one here, let's put it. If I can't get the 6k minus 1, means I have to choose the other one. Okay, it's not possible to introduce a minus there, which means the first choice that you chose won't work. So let's redo it. Are you following?
Yeah.
I hope that you are in a good shape. So here, what that means is, instead of using 6k and k, it won't work. So let's split this and write it as 6k squared minus, this becomes minus 3k minus 2k plus 1. Okay? Right, now it makes sense. Do you see it? Okay, how many of you see that it makes sense now for me to carry on? Okay, so you check out the common factor of 3k, then you get 2k minus 1. Then here it will be minus 2k minus 1 equals what? 0. Then you get 2k minus 1, okay? And that one will be times 3k minus 1. This is equal to 0. So what this means is that k is going to be a half, right? K is going to be a half, and the other k is going to be 1 over 3. Okay? Then let's go back now to the substitution here. So when k is a half, it means that a half will be equal to x to the power of a half. And then remember, if I want to carry on here, I just have to multiply the exponent of x by its reciprocal, which is a 2. So I have to square this side here, then multiply that by what? By 2. So in the end, you get x equal to what? Quarter. That x equal to a quarter, right, is this. See this x equal to a quarter here. Are you following? Right? Then let's do the second one. So when k is equal to a third, okay, I factorize the up to that. Yeah, you equate each binomial to 0. Then you solve for k. All right.
Isn't the other method?
So when k is equal to a third, so you get a third is equal to x to the power of a half, right? To make the exponent on the right equal to 1, you square both sides. So we square here, then we also multiply that. So you get 1 over 9 equal to x. Okay. Now, I'm aware that the second method can be a little bit more complex. Okay. But because of the nature of this class, I might have to show you that. Okay. Than to just talk about one method of doing this, the same question. Okay? And I'm sure, is there anything wrong for you to have more knowledge? It's actually an advantage. Okay? It's an advantage. Okay? All right, let's move on to the next one. Well, I am not sure how some of you approach this question, but I'm sure you can see here that the exponent of x for the first term is a half. For the second term, it's negative a half. Okay? What that means is x to the power of a half is not twice. Okay, the exponent here, that is a half, is not twice minus a half. So for this question, the best way is to convert the negative exponent to a positive. Then find the LCD. Okay? So I can write this as x to the power of a half minus 10 over x to the power of positive a half. And this is equal to 3. Okay? I can't create the quadratic equation directly from the original question. Okay? Because the exponent of the first term is not twice the exponent of x in the second term. Okay? Now you need to find the LCD. Let me warn you. I know that some of you might not be big fans of algebraic fractions, but they are an important part of maths. That's why I did algebraic fractions in grade 9, then in grade 10. In grade 11, we don't teach you algebraic fractions. We expect you to know. Okay? So the LCD here is going to be x to the power of a half. You see now the advantage of talking about method 2, right? Because method 2 has got some similarities with this one. Yes?
So from can you use K method and use K instead of X?
Yes, you can. Which is what I'm going to do. You can use the K method from here. Okay? You can use the K method, which means K is going to become your what? Your LCD. That would be easier now. But I'm not going to go via that way. I'll substitute the K later. So here I'll find the LCD and we get x to the power of a half squared minus 10 over x. Okay, so the minus 10. I found the LCD, so I'm multiplying every 10 by the LCD. So this becomes 3x to the power of a half. Then I can bring in now the k now. So if I say let k be equal to x to the power of a half, that means I'll have k squared, take that 3x to the power of a half to the left, I'll get minus 3k minus 10 equal to 0. Also, if you are scared of working with the x to the power of a half, then do your substitution straight away here. Okay? Put k here, put k there. But still, you need to find the LCD. Still, you have to find the what? The LCD. So I prefer to find the LCD first, then I'll bring in the K method. Alright? So now we can factorize this. Okay? So that would be K minus 5 times K minus times K plus 2. Right? So our K is going to be 5, or K will be negative 2. Okay? Then we need to find X. When K is 5, what is X? So where there is K here, we put 5. So you get 5 is equal to x to the power of a half. We have a rational exponent there, so this becomes 5 squared, and that becomes x. Okay, you should know why now. The answer will be x equal to 25. That's one of the answers. Yes? Square what? This one here. Okay. Look, if our LCD is x to the power of a half, if I want to eliminate this denominator here, it means I have to multiply every term by x to the power of a half. So what that means is I'll multiply this x to the power of a half by x to the power of a half. So it will become x to the power of a half times x to the power of a half. And this is the same as x to the power of a half all squared. If you multiply this x to the power of a half by that one, you will come to that. Are you following? Right? So when k is negative 2, when k is negative 2, we have negative 2 equal to x to the power of a half. So this becomes a half. Then you square that. That will be equal to x. So x will be a 4. Okay, let's check that. He's saying there's no solution, so let's prove that. Maybe you are right. Okay, wait. No, let's check it. So let's substitute x equal to 4 back into the original equation. Right? So if I put x equal to 4 here, what is 4 to the power of a half? The 2. If I put 4 here, it means I'll have 4 to the power of negative a half. Now, 4 to the power of negative a half is the same as 1 over what? 1 over 2. Do you agree with me there? Use your calculator. Right? So, a half times 10 will give you a 5. So here you have a 2 minus 5. Right? And that will give you a 3. Now, you can see that you've got a 2 minus 5 there, which means that that's not true, which means this is not a solution. So you are right, Amasha. So that's not a solution. Okay. So what this means is we only have one solution, which is x equal to what? 25. Yeah, sometimes you might need to test your answer. Okay. Sometimes you might have to test your answer. Okay. So here, what this means, you can say no solution. So we only have one value for x. All right.